This is the video for Chapter 10.1 written homework textbook problems. The first two problems are problems 9 and 10. Instructions state to determine the null hypothesis and alternative hypothesis, or those are given, and determine whether it's a left-tailed test, right-tailed, or two-tailed, and what parameters being used. And so in these cases of problems 9 and 10, we do need to recall from our notes what we're doing here. We're given a null hypothesis, which is a statement to be tested. Alternative is a statement that we're trying to find evidence to support. And then we've determined that there are three types of tests we can run. One's called a two-tailed test, and that involves when we say something is not equal, when our alternative hypothesis is some parameter is not equal to some value that was stated in the null hypothesis. That's a two-tailed test. A left-tailed test is when we say that parameter is less than, and a right-tailed test when we say it's greater than. And so in those situations, what we're really doing when we're talking about tests, we are referring to the normal curve and kind of looking to see the probability of something occurring. And so when we talk about those tails, we are referring to them. We'll talk about that a little bit later. So on problem number 9, this parameter here, the parameter being tested, right? The parameter is a mean value. That's a mu. Remember, you can't call that m. People still call that m, or this is a mu, right? Which means population mean. And so make sure you're using the right language. It's not m, it's not u, it's a mu. And in this case, since this is a greater than symbol, this is a right-tailed test. Number 10, the parameter is p, which is the population proportion. And this is, since it's a less than, we would say this is a left tail test. And again, I'll explain more what we mean by that. And it is referring to the normal curve. Let's go ahead and look at now problems 15 and 20, 16 and 17. The instructions are to determine the null and alternative hypothesis, explain what it would mean to make a type 1 error, and explain what it would mean to make a type 2 error. Again, to go back to, you got to go back to your notes and kind of recall what we're doing. We're testing to see if we can find evidence that the null hypothesis is true, which is back to alternative hypothesis. Sorry, the alternative hypothesis is a statement that we're trying to find evidence to support. We're trying to find reason to support it. And when we collect some words, we try to determine if we can support it or not support it. And so let's look at that situation now. Historically, time to order and deliver pizza at Jimbo's Pizza was 48 minutes. Jimbo implements a new system for ordering that he believes will reduce the time required for his customers. And so in this case, we're looking for here historically the time to order pizza. So there's a mean value right there. And so in this case, the null hypothesis for this one is going to be that the mean is equal to 48, that there is no difference from last time, and that the alternative in this case is going to be believes the time required, where is it? And once a new system for order believes will reduce time, so he believes the mean is now less than 48. And so he wants to test that. We want to find reasons to support this. So we would take a sample and then determine that. But that's for part A. Now, when we test it, there comes to be some conclusions that need to be made. And so we have type 1 and type 2 errors. So B says, explain what it would mean to make a type 1 error. So after we collect some information, he samples times it takes to deliver pizza, order and deliver. A type 1 error would mean concluding that Jim's new ordering system reduces the time required to get a pizza to his customers, when in fact Jim's new system does not reduce time. And so we have this conclusion. We say, yeah, the system does work, but when in fact it doesn't. That's a type 1 error. A type 2 error would mean that concluding that Jim's new ordering system does not reduce the time required to get pizza, when in fact it actually does. So again, our analogies between type 1 and type 2 errors are related to the idea of a jury, right? And you think of um, a situation when a defendant is guilty and then they say not guilty. I was looking for the descriptions here. When we say the defendant is guilty when they're not guilty, and then you can also have a defendant who's not guilty and being guilty. And so those are the variants of type 1 and type 2 errors. Let's go ahead and look at the next one here. According to the National Association of House Builders, the mean price for an existing single home is $245,700. The real estate broker believes the existing home price and neighborhood are lower. And so in this case, we will then have a null hypothesis again to say that the mean, that there's no difference. We would say that there was no change. We would say that was the case. The alternative is that the mean is less than. So we want to see if there's evidence to support the real estate brokers. And again, just coincidentally, these both turn out to be left-tail tests, both mean values, but again, we can involve proportions or means in these situations. And then once again, what are the type 1 errors and type 2 errors? So the type 1 error in this case would mean that concluding that the existing home prices in the broker's neighborhood are lower when in fact the home prices are not lower, right? So we say, no, those home prices are lower when in fact they're not. That's a type 1 error. A type 2 error would mean that that the existing home prices in the neighborhood are not lower, but in fact, when in fact the existing prices are lower. So type 2 would mean that we conclude that the prices are not lower when in fact they are lower. And again, that analogy has to do with saying somebody is not guilty when in fact they are guilty, or again, saying someone is guilty when they're not guilty. And so those are type 1, type 2 errors. Let's go ahead and look at problem number 20. According to the Center for Disease Control, 19.6% of children age 6 to 11 are overweight. A nurse thinks the percentage who are overweight is different. And so in this case, we have a null hypothesis. The proportion is equal to 0.196. The alternative, what the nurse thinks, thinks the overweight is different. And so in this case, this would be a two-tailed test because the nurse thinks that it's different than 19.6. This would be two-tail compared to those other two, and this is a proportion. And then what are the type 1, type 2 errors for this? A type 1 error in this situation would mean that concluding that the percentage of overweight children in the nurse's school district is not 19.6 when in fact the percentage is 19.6. That's a type 1 error. Type 2 error would mean that the percentage of overweight children in the nurse district, concluding that it is 19.6 when in fact it's not. And so again, we have these two distinct situations of type 1 and type 2 errors for these situations where we make a conclusion, we find evidence to support this and say it's not 19.6, but it actually is 19.6, or the vice versa. We find evidence not to support this when in fact it is not equal to 19.6. Let's go ahead and again, on the next lessons, we actually run the tests. We're just setting them up right now. So on the next one, 35, a can of soda is labeled as containing 12 fluid ounces. The quality control manager wants to verify that the filling machine is neither overfilling or underfilling. Determine the null hypothesis that would be used to determine if the filling machine is calibrated correctly. So for part A, the null hypothesis is an alternative hypothesis. A can is labeled as containing 12 ounces. And so in this case, we're saying, is the average weight equal to 12? And in this case, the alternative that is neither overfilling or underfilling. And so the alternative would be that it's not equal to 12. That's what we'd be doing there. That's our null hypothesis, that it actually is filling 12. And then the alternative is that it's not filling 12, which it could be over or under. The quality control manager contains a sample of 75 cans that measures the contents of the 75 cans. The sample evidence leads the manager to reject the null hypothesis, write a conclusion for this hypothesis test. So in this case here, we got to go back to our notes. Let me see if I can find where exactly we need to be looking in our notes. When we write a conclusion, we write a conclusion somewhere here. Where is this statement? Right here. The conclusion to a hypothesis test is always as follows. There is sufficient evidence to conclude that, and insert the statement in the alternative hypothesis. So we're always going to say there is or is not sufficient evidence to support the alternative hypothesis. And so that goes from our notes. And so on this solution here, what are we going to conclude on B? On B, we're going to conclude that there is sufficient evidence, right? The sample evidence leads the manager to reject the null hypothesis. So when we say that, we're saying this is bad and this is good. So that means there is sufficient evidence. There's sufficient evidence to conclude, I'm getting this from our notes, that the filling machine is, it's either over or under either over or under filling the cans. So that's what we have there. Part C, suppose in fact the machine is not out of calibration, has a type 1 error or type 2 error been made. And so in this case right here, we are rejecting. So it says suppose the machine is not out of calibration. So what's happening here is we're rejecting the null hypothesis when in fact the null hypothesis is actually true. And so when we do that, that's called a type 1 error. We're rejecting the null hypothesis when in fact the null hypothesis is true. We're saying that no, that machine's messed up, but the machine is actually not messed up. That's a type 1 error. To help you sort out that thinking again, we have this table that helps us figure this out. A type 1 error occurs when you reject the null hypothesis and when the null hypothesis is actually true. You're basically saying guilty to the defendant when he's not guilty. And then a type 2 error is saying not guilty to the defendant when the actual defendant is guilty. So that's what you could, that diagram helps us with that. And so then finishing off, that was C. Management has informed the quality control department that it does not want to shut down the filling machines unless the evidence is overwhelming that the machine is out of calibration. What level of significance would recommend the quality manager explain? If this is where you would choose a level of significance when we do a test, you would choose an alpha level of somewhere around, we want overwhelming, so like we want to be 99% sure. So we would want to pick a alpha that's small, because in that case we're less likely that the null hypothesis will be rejected. And so we want to make sure that and I guess I'll put a reason, because a low level of significance, low level 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 significance, lo will make it less likely to reject the null hypothesis. And in this case, the null hypothesis is that it is working, the machine is working. So a low-level alpha would mean we would really need overwhelming evidence to reject it. That's it.